All right, so we know that pitch is determined by the wavelength of a sound wave. Wavelength or frequency, you can kind of use those terms interchangeably. But in terms of how does wavelength determine the pitch of a sound, there are actually two different theories about what's happening within the ear specifically that allows the physical structures of the ear to record frequency or record wavelength and then turn that into a determination of pitch. So in this video, we're going to just briefly go over the first of the two theories, which is going to be the place theory. So the place theory was proposed by Hermann von Helmholtz. You should recognize that name. He also helped come up with the trichromatic theory of color vision, the young Helmholtz trichromatic theory of color vision. So obviously he did a lot of work in sensation and perception, and specifically in psychophysics. And the place theory generally says that the different frequencies of sound waves are going to ultimately activate different locations along the basilar membrane. If we look back at our diagram of the ear, this purple portion right here is the cochlea. And you can see that the cochlea is coiled in upon itself. Well, it's coiled around what's known as the basilar membrane. The basilar membrane itself actually creates the coil. And so the inner lining of the cochlea is what we call the basilar membrane. And so when vibrations are passed from the eardrum, through the ossicles, our hammer, our anvil, our stirrup, through this oval window right here into the fluid-filled cochlea, the vibrations start to shake the fluid, but then also shake that inner lining of the basilar membrane. And the place theory says that if you have a high frequency sound, you're going to see really large vibrations near the very beginning of the membrane, the very beginning of the membrane being really, really close to that oval window. If you're dealing with a low frequency sound, you're going to see really large vibrations near the end of the basilar membrane. So if we were to uncoil the entire inner lining of the cochlea, as this image shows here, you can see right here is where we're going to see those really, really high frequencies, which are activating the basilar membrane really close to the oval window. And all the way out here with that membrane all the way uncoiled, we see the really, really low frequencies. Now, problem with the pitch theory is it does a really good job of helping us understand how we can determine high pitches, but it's not as exact with low pitches. There's a little bit more of precision when we're trying to locate the really, really high pitch, but with low pitch, it doesn't seem to be as precise. So place theory is one of the ways that we understand pitch discrimination, but it really works well for high pitch as opposed to low pitch. So to understand how we're able to determine or discriminate between really low pitch sounds, we need another theory, and that other theory is going to be frequency theory.